I was sent a question about difference of cubes and sum of cubes and how you would use that to factor out a polynomial. So I wanted to go over an example. When we're talking about special forms, we do have a special form for the sum of cubes or difference of cubes. So if you have a perfect cube plus another perfect cube, it will factor into a plus b times a squared minus ab plus b squared. And this quadratic that it factors into over here is always prime, so it shouldn't factor any further. Difference of cubes would be a cubed minus b cubed. When that factors, it is a minus b times a squared plus ab plus b squared. So they want us to apply one of these two forms to simplifying and performing this operation here. When I look at these polynomials to begin with, I notice that on the top here, these both have an x squared. I'm going to go ahead and factor that out of each of them. When I do that, I'm left with 8y to the third plus 27. Down here, same thing. I'm noticing they both have an x squared, so I'm going to go ahead and factor that out of each of them. When I do that, I'm left here with 343 y to the third minus 1, because x squared divided by x squared gives me 1. When we have division involving rational quantities, remember we always turn those into multiplication, and we flip it. So this is going to now be on top, and this will now be on the bottom. When I'm looking at this polynomial, I notice that all three of these terms, have an x to the third, so I'm going to factor that out. And when I do that, I'm left with 49y squared plus 7y plus 1. This one, which is now down here, also both of these have an x to the third. And we're left with 4y squared minus 9. Before I start factoring any further, I have an x squared over an x squared. That means I should be able to cancel those. An x cubed over an x cubed, I should be able to cancel those because they have been factored out as their own individual factors and they match exactly. That's why I can cancel. I still have to deal with these remaining polynomials. 8y to the third, this is a perfect cube. If I took 2y and I cubed it, I would get 8y to the third. 27 is also a perfect cube. If you take 3 and you raise it to the third power, you get 27, which means I should be able to use this form up here to factor this polynomial, this binomial, which is a sum of cubes. So when I do that, we said we had to cube 2y to get to the 8y cubed. So I'm going to have 2y plus 3, because 3 is what you have to cube to get that 27. Then I'm going to have this quadratic factor that says take that first thing you had and square it. So 2y, if I square it, I'm going to get 4y squared minus, then it says multiply the two values you have in here. So that's going to give me 6y. And then plus b squared. So this thing squared is going to give me 9, so plus 9. So we're here so far. Here on this, 343y to the third is also a perfect cube. If I take 7y and I cube it, I will get 343y to the third. And 1 is a perfect everything. So if I take 1 and I cube it, I'm still going to keep on getting 1. So it also qualifies for using that form that we talked about earlier. So I need to have a minus b because this is a difference. So I'm going to have 7y minus 1. Then I have to square the 7y to give me 49y squared. I have to multiply these together. That's going to give me 7y. So plus 7y. And then this squared, which is 1, will still be 1. So plus 1. Then here I have 49y squared plus 7y plus 1. I have another one down here That means I shouldn't have to factor this anymore. I'm going to leave this one alone because it's going to allow me to cancel it with this one. So I have 49 y squared plus 2y plus 1. Down here I have 4y squared minus 9. Neither of these are cubes, but they are actually perfect squares. If I take 2y and I square it, I will get 4y squared. If I take 3 and I square it, I will get 9. If I have a difference of squares, that will factor into conjugates of their two forms that had to be squared to get them. So this should factor into 2y minus 3 and 2y plus 3. And so now, like I said, I have this, which matches exactly with this. So those two cancel each other out. I have a 2y plus 3, which cancels out exactly with this other 2y plus 3. And then I have up here left over this 4y squared minus 6y plus 9. And down here I have the 7y minus 1 and the 2y minus 3. I hope that helps. Please keep sending your questions.